In this film, we shall be investigating the universe's smallest building block, the atom. The atom, which sometimes appears as the title of a rather boring subject in textbooks, actually contains very important truths, as well as providing us with important evidence of the existence of God. Atoms are everywhere. Everything we refer to as matter, in other words, our own bodies, our rooms, our homes, all consist of atoms. The reason we are able to perceive the atoms around us as matter is that the electrons in the atom's orbits collide with the photons, and atoms attract or repel one another. You are not even touching the chair you are sitting in at this moment. In fact, the atoms in your body are repelling those in your clothes and the chair, and the feeling of touch arises in proportion to the force of that repulsion. We can never actually touch the matter we hold in our hand. If we did actually touch it, we would enter into a chemical reaction with it. That, of course, would mean that there could be no life. Each one of the trillions of atoms that comprise your body is full of electrons that spin round at a speed of thousands of kilometers a second. You do not realize it, but there are atoms that revolve at an amazing speed and never lose their balance, break up or fragment in every single part of your body. So how did this equilibrium come into being? It all began with a huge explosion, known as the Big Bang. The smell of soil, the bright blue of the sky, everything was at one time concentrated in a single point of infinite density and temperature. Scientists calculate that this moment took place some 15 billion years ago. That moment was the beginning of the process in which the atom, the building block of matter, and subatomic particles formed in the wake of the explosion and combined together.
Büyük bir patlamanın ardından oluşarak bir araya gelme sürecinin başlangıcıydı.
The building block of all the systems that would come to constitute life, calculated right down to the finest detail, began to form from that first moment, within a specific plan. The structure of the atom is described in great detail in books on chemistry and physics. Yet there is one important point that is always glossed over. How did a system based on such sensitive balances, with such a tiny volume, come into being? Why did protons and neutrons come together in the wake of the Big Bang? And why did electrons begin to revolve around them? How is it that this unbelievable phenomenon was repeated everywhere in the universe, and that an almost infinite number of the flawless structures known as atoms came into existence? All these questions about the origin of the atom lead us to a single conclusion. God creates the entire universe. Scientists refer to this extraordinary creation in the universe as fine-tuning. This, in turn, reveals the existence of a creator who rules the whole universe. That creator is Almighty God, Lord of the worlds. He is the originator of the heavens and earth. When he decides on something, he just says to it, "Be," and it is. Atoms are particles so minute that it is impossible to view one even with the most powerful microscopes. The diameter of an atom is only of the order of 1/1,000,000th of a millimeter. Let us envisage this by means of an example. If you say, for instance, that you want to see the atoms in this key, then we would need to magnify that key to the size of the Earth. Every atom inside the key magnified to that extent would be no larger than a cherry. So what are the contents of such a minute structure as this? Let us investigate the complex and flawless structure known as the atom together. Every atom consists of a nucleus and electrons revolving in orbits far away from the nucleus. There are other particles inside the nucleus, known as protons and neutrons. Until recently, it was thought that these were the smallest components of the atom. In the light of the latest scientific findings, however, it was discovered that protons consist of particles much smaller than themselves, called quarks. The nucleus is located right at the center of the atom and is made up of a certain number of protons and neutrons, depending on the properties of that atom. The volume of the nucleus is equal to a 10/1000,000th of the volume of the atom. It is, of course, impossible to conceive of such a size. Let us therefore continue with the example of the cherry. If we magnify a key to the size of the Earth, then each atom inside the key would be the size of a cherry. If we want to see the nucleus in one of these atoms, then we would have to change the scale again. The cherry representing our atom must become a large ball 200 meters in diameter. Even at this unbelievable scale, the nucleus of our atom would not become any bigger than a very tiny grain of dust. Yet there is one thing even more surprising than that. Although its size is 1/10,000,000,000th of an atom's size, the nucleus's mass comprises 99.95% of the mass of the atom. How is it that something constitutes almost all of a given mass, while on the other hand, occupying almost no space? The density constituting the mass of the atom has not been distributed equally over it. In other words, just about the whole mass of the atom is concentrated in the nucleus. The figures prove that a large part of the atom consists of empty space. Put at its simplest, the atom consists of a nucleus in the middle and electrons revolving around it. There is nothing between the nucleus and the electrons. This microscopic distance, in which nothing exists, is in fact a very large one on the atomic scale. Let us try and conceive of these dimensions by using an analogy. There is a great space lying between the basic particles. If I think of the proton of an oxygen nucleus as the head of a pin lying on the table in front of me, then the electron revolving around it draws a circle passing through Holland, Germany, and Spain. The protons and neutrons inside the nucleus of the atom constitute 99.95% of the mass of the atom and are the source of the variety of elements on Earth. There are 109 elements on Earth. Some of these elements are very familiar to us, such as oxygen, hydrogen,